And now I would like to invite Johanna. You will continue the topics of aflatoxins, not only in children, like previous talk, but also you look at also aflatoxin level at pregnant women in the community of Nepal.
Yes, so good afternoon. I'm very pleased to be here and really appreciate the easy segue into my presentation because it's also about aflatoxin, focusing on the seasonality piece of it. So I'm presenting on seasonality of serum aflatoxin levels in pregnancy and in children in their first year of life, and this is data taken from a birth cohort study that we have in Nepal. So just a little bit of background, even though it overlaps a little bit with the previous presentation, aflatoxins are a type of mycotoxin that can be found in foods such as corn and peanuts and also in other foods such as chilies. Aflatoxin B1 has been declared a carcinogenic, and it's also been linked to the poor linear growth and to immunosuppression and other health effects. The mold that produces aflatoxins tends to proliferate under hot and humid conditions, so typically in tropical areas is where you'll find it. And there have been some studies that have looked at aflatoxin levels in food crops and seen some seasonal variation, but little has been done in terms of serum aflatoxin levels and seasonality. And so we set out to do that. We wanted to assess aflatoxin exposure in women and children and really focus in on the role of seasonality in the patterns of exposure. And we were able to do this because of our study design. And our study is called the AFLACOHORT study. It's an observational birth cohort study that started in 2015. The primary objective of this cohort study is to understand the relationship between mycotoxins, specifically aflatoxin is what we're focusing in on, and its relationship to birth outcomes and to linear growth in children. We're working in the Banke district of Nepal, and this is in the southern part of the country, in the Midwestern area. It's a very warm part of the country, very flat, agriculturally productive area, so not the Mount Everest that you think about, it's instead the opposite. We recruited 1,675 women in pregnancy, and their children, once they were born, they became our participants. We collected data on a rolling basis, which allowed us to evaluate these seasonal patterns. And the measure we used for aflatoxin was serum aflatoxin B1, which we collected once from the pregnant women, and then we collected in the infants 4 samples from the infants at 3 months, 6 months, 12 months, and 18 months of age. And we used HPLC, fluorescence detection method, to analyze for aflatoxin B1, and all that analysis was done at the University of Georgia. This diagram just kind of summarizes the structure of our study. We had 2 phases. Our original phase 1 allowed us to follow up with the women from pregnancy up to when their children turned 1, and we visited the mom and the child at birth, and then every 3 months after that. And then phase 2, we were very excited to be able to add on because it allowed us to visit those children twice more at 18 months and at 24 months of age. And as you can see here in the 4 boxes, the 4 black boxes, that's when we had the blood samples from the children to analyze. It was a very comprehensive interview in which we asked about diet, we asked about agricultural production, health, household composition, and this was all data that was collected electronically. And then our enumerators were all assigned to a certain area of the study, which allowed us to build a lot of trust and rapport with the participants because it was always the same person that was visiting them. And all the blood samples were collected within a week of having interviewed the participant. And it was also by 5 of the same study nurses, so the participants were familiar with who was coming to their house to collect the blood sample. The descriptive statistics and bivariate analyses were all done in Stata, and we used logged aflatoxin levels because of the right-skewed nature of our data. So this table shows you a summary of 4 of the 5 time points in which we have aflatoxin levels for our participants. From the pregnant women, we collected about 1,650 samples, and from the children at 3 months, 6 months, and 12 months, we collected about 1,300 blood samples. And I just want to highlight that the prevalence of aflatoxin exposure was pretty high. We had about 94% of the women who showed some aflatoxin in their blood, excuse me, and then about 75 to 80% of the children, depending on the time point. And mothers had the highest mean levels, which you'd expect because they're eating a full adult diet. And then the lowest levels were found in the children at 3 months and 6 months, and then they were greater at 12 months because they're starting to eat more foods. And I just also wanted to highlight the maximum levels that we found, which were 147 for the women, and then 24, 41, 84 for the children. So kind of increasing also as the age of the children increased. And this graph just shows you that right skewedness of the data. It's actually the logged aflatoxin data. And so even though most of the values concentrate on the left-hand side, there were some of those higher values that pulled that curve over to the right, and therefore we always use log transformed data, even though it still didn't address the problem to the fullest. And then we wanted to set out then to understand a little bit better what the patterns of aflatoxin exposure were, because we had so much data, repeated data on these children, and then we had mom's levels that we wanted to look at too. And this shows you just the mother's levels. The red line is the mean logged levels. And as you can see in the kind of the winter months, so starting in November through February, we saw higher mean levels. So women who were measured during those winter months, which also coincide with post-harvest season, they had the highest levels. And the lowest levels were seen in the mothers that were measured in the summer months. And then this shows you the same thing, but for the children at 3 months, 6 months, and 12 months. So these are the 3-month-olds. Where we saw more of us, the springtime was when we saw the higher levels in the children. And we saw a similar pattern where the lowest levels were in the children who were measured in the summer months. And the 6 months, this is where the pattern wasn't as clear, but we saw also kind of the higher levels in the end of the winter months, and then the lower levels in the summer months. And with the 12-month-olds, we saw that kind of more end of winter, spring as the highest mean levels. And this is just a dichotomous variable that we then created, and we said if we're seeing kind of these higher winter month levels, do those participants who are measured in the winter, so from November through February, have higher levels? And across the board for moms and children, that was the case. They were significantly higher, always in those who were measured in the winter months. And this just shows you the 3-month-olds, the 6-month-olds, and 12-month-olds. That's the same story. So what we take away from this analysis is that there is a high occurrence of aflatoxin exposure in this region of Nepal in both the pregnant women and the children. The seasonality does seem to be playing a significant relationship with the pattern, with the exposure levels, with the moms being very clearly in the winter months and with the children kind of in the winter, springtime where we're seeing the highest levels, so post-harvest. And the levels of exposures and the relationship to health outcomes could be modulated by seasonality, and this is something that we're taking into consideration in our bigger research question that's looking at the aflatoxin levels in relationship to linear growth, because this gives us a little more granularity on the situation of these children, because we followed them for so long, and it really gives us an idea of what was maybe going on in their lives. And then it's also something, the seasonality that we're seeing is something that should be considered in any mitigation strategy to reduce aflatoxin in the food system, because it obviously has some peak times. And I just want to thank our collaborators and team who have been collecting all this data for about half a decade now, which makes me feel really old. But without them, it wouldn't have been possible. And I thank you guys for coming to the presentation.